Hello, everyone. Welcome to the FreeCAD Rocket Workbench presentation. Um, I do apologize. I have a multi-screen setup, so I'm not going to be looking straight at the camera all the time. I'm going to be looking slightly askew, but I am paying attention to you, so rest assured there. Okay, so let's get into it. So I'll start by introducing myself. I'm a longtime Rocketeer, having started in the 70s, but I went for a long period, like many, where I wasn't actually building rockets. So definitely a born-again Rocketeer. In my day job, I'm in computer programming. I'm a solutions architect. So I have a lot of software experience, which is how this project really came to be. Okay, so let's start with why FreeCAD. Well, at the time, I was building a fairly large project, a 1/22nd scale model of a Saturn 1B. And this is what I was producing. My CAD options at the time were, well, there were many, but there were a few requirements I had. I was traveling a lot for work at the time to places with spotty internet or perhaps with national firewalls that would prevent using some popular cloud software. I wanted something that was local to my machine, that I could travel with easily, preferably with multi-platform support, because at the time I had Macs, PCs, and Linux, and luckily FreeCAD runs on all of those. But no cloud requirement was a pretty key requirement for me. Now, FreeCAD itself, one of the nice things about it from the point of view of working with extensions to it for rocketry and things like that, it exposes everything in Python. So you can reference all those objects using Python. Even though under the hood, most of it is implemented in C++, it really looks like Python to the programmer. And I'll show you a bit of that as we go through. One of the advantages of exposing that Python is it makes it very easy to extend through the use of macros. And that's kind of how I got started. So when I first bought my 3D printer, I started with a quick program in OpenSCAD to draw the shapes for a nose cone. I quickly progressed from OpenSCAD, and so that migrated over to FreeCAD. And I've also implemented it in Fusion 360 in the past, but with their licensing changes, I'm exclusively back onto FreeCAD now. So those macros are actually a pretty useful way to extend the product to create some very specialized parts or things that aren't necessarily simple from a CAD user interface point of view, but are actually pretty simple from a programming point of view. So it makes it pretty easy to do that. Now, once you've written a macro, you're halfway to creating a workbench. So what is a workbench? In the context of FreeCAD, it has workbenches, which are specialized workflows. So, for example, there are workbenches for doing what you would typically think of the additive CAD, where you would have a cube and a cone and a sphere, and you would combine those into useful shapes. But they do a lot more than that. There are workbenches for architecture, for shipbuilding, for paper airplanes. So you can actually do a lot of these things, and it's very easy to create your own workbench. And I'm going to come back to that in a few minutes. One other feature of FreeCAD that makes it very useful from a rocketry point of view is it interfaces with external software fairly easily. I mentioned that I did OpenSCAD. Well, if you're an OpenSCAD programmer, you can use that through the FreeCAD user interface. But that's really the beginning of it. So you have things like Calculix, which does finite element modeling, OpenFOAM, which does computational fluid dynamics. You have some mesh generators, GMSH, NetGen, some others. But there are other instances where it interfaces with the external programs as well. So where OpenRocket, if you went to the talk this morning, great software. It's designed for simulation. FreeCAD is more designed for manufacture. So we can take our designs and 3D print them. We can export them for laser cutting, for CNC machining with the built-in workbench called the Path Workbench. That transition is very useful for us. So which comes to the point of why a dedicated workbench? Well, a lot of this can be done simply without one. So for example, I did have a macro that would generate nose cones. When the idea of a workbench was first brought up, my big question is why? I didn't think there was enough there to really support a dedicated workbench. But as I started digging into it and looking at possibilities for it, the idea became a little more fully formed, and certainly once you see it here in a few minutes, you're going to understand why a workbench dedicated to rocketry makes a little more sense. Okay, so I'm not going to make you an expert on FreeCAD in an hour. There's a lot to it, even just the rocketry workbench, there's a lot to it. But I will give you the basics for getting started. So one of the first things you want to do is install OpenFreeCAD. Okay, so freecadweb.org. Now the link is in the presentation materials. If you go into the description for the presentation materials, you will find them in there. So you have access to all of this. But you download the software, you install it like you would any other installer. It supports Linux, it supports Windows. I'm not sure of the current support for the Mac. I know it wasn't very good in the past, but I also know there's been a lot of work done on it. But I haven't had a Mac in a little while, so I haven't really worked with that one significantly. But download it, install it, you're good to go. Okay, so I've already done that. Here's FreeCAD. Okay, we'll come back to this. So the next step is installing workbenches, and there are quite a few. So let's look at how that's done. It's a pretty straightforward process. If you go to the Tools menu, the last entry, you will see something called an add-on manager. So what it does when you select the add-on manager is it actually goes to a GitHub repository that has links to all of the workbenches. And as I mentioned, there's a lot of them. There's 3D printing tools, there's airplane design, computational fluid dynamics, a curves workbench for working with specialized curve shapes and so on. If you're into electronics, there's an integration with KiCad, so you can actually integrate your project from KiCad and create a 3D model of it. The one we're interested in is Rocket. Okay, so when you do that, when you select the Rocket Workbench, it brings up a description of the Rocket Workbench that comes from the GitHub repository. Now, in this case, I've already got it installed. But you can uninstall, or you should have the install button here if you don't have it currently installed. When you're installing, what it's doing is actually cloning the repository from GitHub, and that just means it's making a local copy of it. When you hit close, it's going to ask you to restart FreeCAD so that it can load the workbench. Okay. Now, the workbenches are all available from a drop-down list here. A number of them are built into the core product, but there are some that are external. So the Rocket one is external. There are some configuration options you can set up once you've installed it. You go to Edit, Preferences. Okay. There's a whole bunch of preferences that you have in here. So one of the big ones on the general screen is units. So it supports your units in a variety of formats. You can do metric, you can do the US customary and so on. You can even go into some of the archaic measurements such as slugs and so on. So I don't really use those. Typically in the standard metric, I have done some modeling, for example, for the Saturn 1B, where I've switched to the US customary, but for the most part, I'm either in standard metric or the metric for small parts, which is useful for CNC. In the add-on manager, actually, I'll come back to that later. Never mind. Okay. So one last thing about units is even with my units set to metric, I can still use imperial measures. So for example, if I entered 2.0 and a double quote, that'll take it as 2 inches, or 2.0 IN. Most of the fields will accept any standard supported measurement and use that accordingly. So it's good if you're, like I said, working metric in my case, but you have 1 or 2 imperial measurements that you need to add. Startup options. Okay, so this one I will go back to my FreeCAD. So startup options, there's a few that are useful. You go to the start. This is a very useful one. Switch workbench after loading. So if I create a new project, I have it set up to automatically jump into the Rocket Workbench. If you have another one that you prefer, you can select it from here as well. So that just saves a lot of time. In the general, we also have startup. So this is what loads on the start of FreeCAD. There is a start screen, which you can see here. And you can control things such as how many files show up in the most recently used list. Okay, so we'll come back to that. Okay, so let's talk about the Rocket Workbench. The Rocket Workbench has features that fall into 3 main categories. Components, these are what you're typically looking for: nose cones, transitions, fins, all of the standard pieces. In its current incarnation, it's not like OpenRocket where you would build the rocket. You're actually just building the individual components, and I'll explore that in a little more detail later. Calculators. If you want to calculate things such as the number of vent holes in your rocket, we have a calculator that can do that. So it is generally a replacement for things you might have done using spreadsheets, various online calculators that may not be available to you at the field because of spotty internet connection and poor cell coverage and things like that. So it really is something that runs locally. They are dialogue based, but yeah, there's no real restriction on these. We can certainly add things as required. And I'll talk more about the calculator shortly. Excuse me. Analyzers. This is not fully developed at this point. At this point, there's only one that's there, and that's a fin flutter calculator tool for a very restrictive set of conditions. And I'll talk about that as well. There is potential for integration with other FreeCAD tools, such as the finite element modeling and the computational fluid dynamics workbenches, and I'll talk a little bit more about that later as well. So let's look at these in order. Components. This is why most people are coming to the Rocket Workbench. The whole point about these components is they're fully parametric. If you're not a knowledgeable person with regards to CAD, you can get started and up and running right away. So let's see what that looks like. Oh, come on. There you go. That was painful. So within FreeCAD, I'm going to create a new document. And you can do that in many ways. You can do it file new, you can do the new document icon, or from the start screen, create new. And as I've mentioned, I've got it to automatically bring up the Rocket Workbench. But if you don't, you can, select which workbench you want to start in from the dropdown. Okay, so we have an empty dialog. Let's create a nose cone. Okay, a nose cone has a shape. We support a very large number of shapes. Let's make this a blunted cone. It can be either solid, hollow, or capped. And we'll talk about the capped options here. Okay, so if I select this from the tree view, you can actually, it makes it semi-transparent so you can see what's going on inside. Okay, so we can see that there's actually a hollow space inside that nose cone that will reduce weight, allow you to do a number of features. Okay, and with capped, I have a number of capped options. It can be either solid, which is what we just saw with a bar. Okay, so you can see there's actually a bar across the base. I'm going to rotate this a bit, and you can see there's a bar for attaching a parachute. Oh, wrong menu. Bar, and we also have the option of putting a cross in there for attaching a parachute. Okay. We can play with the standard diameters, the width of the bar, the length, the diameter, the thickness of the cone. In cases where there's a shape parameter, we would have that. And since this is a blunted nose cone, we have a blunted radius at the front. Okay, let's go back to. You can also add a shoulder to this. Okay, and if we look at the shoulder, you can see it's moved our end cap option down to the end. Okay, so this is for a nose cone. We have similar parameters for transitions, for body tubes, centering rings, bulkheads, fins, fin cans, and so on. So I'm actually going to bring up the, let's delete that, and let's add a centering ring. Now, a centering ring is basically a bulkhead with a hole in the middle, so a lot of these options are going to apply to bulkheads as well. So for example, we can have a stepped function. And for example, in this case, you would have a step where the diameter of the smaller ring would fit inside your body tube. The diameter of your other ring would be flush with your body tube. So this is something you might use on a electronics bay, for example. We can add holes around the center. Okay, so if you're doing clustering, for example, you can have these as motor mount sizes, and all of these are adjustable in size. And we could put a notch for a engine hook. Fins and fin cans. I'm going to bring up the fin can. So a fin can, in this case, it's a sleeve design. It would slide over your body tube. You optionally have a launch lug as part of it. You can control the count, the spacing of the fins, the fin cross section. So for example, if you want an airfoil shape, okay. And you can set these independently for the tip and the root, but typically they're linked. And you would set the cord, the sweep, all of that useful stuff. Okay. So the fin can itself, you have basically the same parameters as a body tube. You can add a coupler to this. So if, for example, your fin can is flush with your rocket, this will allow it to slide inside the body tube. And as I mentioned, you can add a launch lug. Okay, so those are the components as they stand at the moment. Okay. Oh, right, part database. If we want to create a part from the database, so we can actually look up, this is the same database. I shamelessly stole this from OpenRocket. So it's going to be very familiar to you. And like OpenRocket, we're now using the curated database by Dave Cook. It's an excellent resource. And yeah, so let's open an elliptical fin, or nose cone rather. So we have all the properties of the nose cone to recreate what's in the database. Now, there is a caveat on this database. It is designed for OpenRocket, which is not CAD software, it is simulation software. There are a lot of errors and issues with the information in the database through no fault of their own. I mean, OpenRocket's doing really, really good for this. But for example, I have a much larger list of supported nose cone shapes. And if you look in the database, a lot of things that are listed as ogive, for example, are going to actually be blunted ogive, which is not supported by OpenRocket. From a simulation point of view, it's not a big deal. From a CAD point of view, it may be. So what you can do is, as you load an ogive, you can then go and modify it. So this was actually a blunted ogive, or not a blunted cone, blunted ogive. There we go. Now it's messed it up. Okay, so let's reload that. Nose diameter must be greater than 0. I'm not sure what error that is loading. So I think I've uncovered an error in my program, which I'll have to go back and look later. Okay. Now, when it comes to nose cone shapes, for example, I'll do a control click here. So basically, I got the list from Wikipedia, which is a surprisingly good resource on shapes and things like that. And I believe, yeah, no, the biconic is not in there, but most of the shapes that are in this list are currently implemented in the Rocket Workbench. So if you need an explanation of what is in there, this is one place to look. There is also documentation on the FreeCAD web wiki. Okay, so you can have look up the information for things like all the nose cone types and shapes, and there's a lot of good examples in here. Calculators. So this is an interesting piece. The intent is to replace spreadsheets and online calculators. So when you're at the field with limited internet coverage, for example, you can still have it on your laptop and run your calculators there. In general, adding new calculators is pretty easy. It's just a matter of creating a dialog to enter the values and, of course, report the results. At the moment, there are calculators for ejection charges, for parachute size, for thrust to weight ratios, for vent hole size, and so on. All of these are documented on the wiki. So this is where, okay, if we look at the ejection charge calculator, this is what it looks like. The calculation, how it's done, and some references for how this came about. Okay, so all the calculations internally are done in metric, actually millimeters even, not meters. So you may find the constants are a little bit different from what you're reading. And honestly, that's a big problem with implementing a lot of this in the Rocket Workbench, is that constants actually have dimensions, but most engineers don't include them. There's no derivation of them. In a lot of cases, they're just magic numbers. So there's been a lot of work put into getting metric versions of those constants and then validating the results. But all of the calculators in here are documented in this fashion. I don't do any calculations without documenting. So along those lines, if there's a calculator you think that you might like to see in here, send me a note and we can discuss how that might be done. All the better if you have references and sample calculations, but if not, they're, I can do research too. So analyzers. So this is basically the untapped potential of the Rocket Workbench. I have done one that calculates fin flutter based on the NACA technical note 4197, which is predates NASA. I think it was 1947 or 48 that they came up with this. So it's a really old document. But if you use FinSim, for example, when it does its static analysis, this is what it uses. Okay, it is accurate for mostly symmetrical fins with little sweep. A little rearward sweep is fine. Forward sweep is a little more problematic. But if you have a highly swept fin, that's not going to be good for that. But let's have a quick glance at that. Okay, so let's create a fin can. I'll just use the default version here. Okay, so I select the fin can and I get my Flutter analyzer. Now, when I do this, it's actually just going to look at the fin shape. It's not going to look at the entire can. So it is smart enough for things like that. Okay. We can select our material from a number of presets. From that, it either calculates the shear modulus based on Young's modulus and Poisson ratio. If it has the shear modulus, it'll use that instead. The maximum altitude just defines the range of your graph so that it's easy to see. The altitude at max speed, this isn't, for low altitude rockets, for typical, HPR, then this is going to be not super critical. If you're going to higher altitudes, like we saw in yesterday's keynote, obviously that's going to be a little more critical because the atmosphere is very different. Okay, we get the flutter speed, we get the divergence speed, and of course, being aluminum, we can go a few Machs with this small fin. Okay, so this is just an example of the sort of things we can do in terms of analysis. I do have some demonstration code that will actually start the process of meshing and setting up the boundary value conditions and so on for a finite element modeling exercise. But that's very much in its infancy at this point, and it's not code I am really good for showing. So the downside of this at the moment, FreeCAD does not have a consistent way of working with materials, so you're going to have to set the material each time. If you have a material, you can actually go in and edit it or add your own. So these are the parameters for aluminum. The other issue we have, so OpenRocket has its own concept of materials, for example, which is fundamentally just density. It doesn't have all the strength and other attributes that we have. So even using Dave Cook's curated database, it just doesn't have this information. So this is an area that needs a little more thinking in the future of how we're going to use it. Now there's another complication in FreeCAD. If I bring up appearance, I can actually set a material here, and really this material is just for appearance. It doesn't actually have any of the properties like density or shear modulus or anything like that. So there's a lot of inconsistency with how this is used within FreeCAD. Okay, so you made your component. You want to do something useful with it. There are a number of options. So for example, using a full fin can like this, I can just export to an STL. I have to select it first and then export. Okay. So I don't want an SVG, I want an STL. Actually, where did I save that? Okay, so let's bring that up. Okay, so here's the STL. I can then bring it up and use my Prusa slicer. Give it a moment for it to load. Okay, so we now have it imported into our slicer. We can then prepare it for 3D printing. For laser cutting, you would export as an SVG. There are some gotchas in there, which I'll be covering in a as yet unpublished video. Or we can, right from within FreeCAD, we have the path workbench. Okay, and this is one that is set up for using CNC devices. I haven't done a lot of work. I do have a CNC machine, but this is fairly new. I will cover that in a future training video as well. Okay. Oh, actually, one other thing about exporting to a STL. This is actually a common problem that gets reported. I've had a couple of bug reports on this, and this is not a bug. You just have to know a little bit about the software to work around it. Okay, so this is the design of the nose cone. When you export it, you can get some artifacts on here, which require a little bit of post-processing in order to get rid of once you've got it printed. There are ways to get rid of this. It is not a problem with the model. It's just a matter of how you're doing the exporting. So if we look at how the export is done, what actually happens is you take your part and you create a mesh for it. Okay, so I'll create the mesh from shape. Okay, and I'll hide the original. Oh, and of course it doesn't show here. Well, what happens with the mesh is it's made of a number of very small triangles. Actually, I know how I can show that. No, I can't. Okay, not yet. And those triangles have a resolution. By default, the resolution is such that you will get these artifacts. Okay, you can improve that resolution, and you do that through the settings. So we go to Edit Preferences. And under Import Export, you have a tab called Mesh Formats. And in there, you have a maximum mesh deviation. And this basically sets the granularity of those triangles. So on a flat surface, the default values work fine. But when you get a lot of curvature, for example, on an ogive nose cone, this is where you start seeing those artifacts showing up. So the way to fix that is to set the default deviation to a smaller value. The trade-off there is you are just creating a larger file with more elements. If you're doing some other post-processing after this, that may or may not come to play. But if you're just exporting, bringing it into your slicer, it's going to create a bigger file, but decrease your mesh deviation, and you will see a noticeable improvement in your part. In fact, these two nose cones, the only difference is that default value. Okay, so we can see the artifacts on one. We do not have the artifacts on the other. So a very quick tip for people using the Workbench to create 3D printable pieces. Current development. So this is some exciting stuff, and it's where things have moved very quickly in the last few weeks. So what I am working on currently is not at all what it looked like when I first proposed this presentation. Okay, so as I mentioned, with the workbenches, okay, in the add-on manager, it downloads the source code from a repository using a tool called Git. And there is a way to automatically preview some of the working repositories, and it involves doing some default settings. Where's my presentation? Okay, so these are the directions here. Bring that up. Maybe. All right, keep coming up. There we go. Okay, so you would have to go in the add-on manager and enable an option to show some of the development branches. Now, when you're doing this, there are some caveats. Save your files. Files are not backwards compatible. And since it's software that's under active development, the file formats may change. So you may produce a file that is incompatible with the with older versions of the software. Okay. Now I'm changing mine slightly differently. So I'm going to exit FreeCAD, and within my development environment, I'm going to change my branch and restart FreeCAD. There we go. Okay. So this development has two major features. Let's create new. The first is what I'm calling a rocket builder. So this is very similar to what you would experience if you're using the user interface for OpenRocket. Okay. So you create a rocket. It has a sustainer stage, add a nose cone, add a body tube, add fins, and so on. Okay, so you would build up your rocket very similar to what you do in OpenRocket. There are some differences in OpenRocket. The tip of the nose cone is X0. In this, the base of the body tube is X0. Okay, so they're kind of reversed. You can see that we actually have the fin set here, which is like a fin, except there are multiples of them. We also have an expanded list of parts. So, for example, I can add inner tubes, couplers, engine blocks. We have launch lugs, but there's also rail buttons and rail guides. Okay, so let's actually look at the rail guide. This one's a little bit different. Okay, so we have three basic shapes for rail guides. Conformal, which will allow you to match your body tube. And I don't have a diameter for this one because it's, okay, there we go. We can have a V-shaped where it's meant to fit a number of different body tubes. We can have a forward sweep, an aft sweep, a notch, and so on. Okay, so again, very parametric. Now, you will notice there's a lot of similarity between these components and what we have in OpenRocket, and that's intentional because, let's open a file. So one of the rockets that was shown in this morning's OpenRocket demonstration is the simple model rocket. Let's open that. And it imports it from the OpenRocket file, okay? It imports the colors. You'll notice it looks a bit different because they have a lot of decals and things like that in the file, and that's something that I'm currently developing, so it's not in there yet. But basically, there's your OpenRocket model. There are some limitations at the moment. I can import but not draw parallel stages, pods, and clusters. I'm going to do just the simple rocket first, get that working, and then add the other pieces later. It's not a project that's going to take 7 years like it did for OpenRocket because things are done differently in FreeCAD. And that's actually one of the issues with OpenRocket and FreeCAD. They do things quite differently internally. So, for example, in the OpenRocket talk this morning, they were talking about how they don't have a geometry manager to manage all of that. Well, FreeCAD does. So how these rockets are drawn is very different. So let's open another one that's a little more interesting. Where is the boosted dart? Here we go. Okay, so we can actually import some pretty sophisticated designs. So this is pretty exciting as well. Now, in terms of going the other way for exporting from Rocket Workbench to OpenRocket, that's going to be a little more of a long-term project. There are some issues. For example, we support a larger number of nose cone shapes than is supported by OpenRocket. Something I can help the OpenRocket project with, but the considerations are very different. So for example, I'm not worried about coefficient of drag, of center pressure, and all of the things that you need to be concerned with when you're doing a simulation model, but you don't need to be concerned with when you're doing a CAD model. So there is going to be a lot of effort required to do a full round tripping, but that is the long-term goal. So this is all pretty exciting. This is very much alpha software, which is to say it's potential for some very serious bugs in there yet. Not all the features are in there yet. It is under active development, but you can test that if you follow the link. There's directions for testing it. And I do encourage you to test it because obviously the software will get better, more people looking at it. Future development, importers for other products such as RockSim, RasAero, and so on. Exporters, as I mentioned, that's a more involved process, but there will be some work done on that. Analyzers, finite element modeling in particular. I want to have a guided workflow for doing fin flutter analysis. FinSim is a great tool for this, but you know, that comes with some political concerns, which if you're familiar with the process is it basically makes it unavailable to most people at this point. Okay. So the goal again is to produce a tool that will allow you to do that analysis without being intimately knowledgeable of finite element modeling. So there's a lot of math. I'm reading some papers and doing some training, and yeah, so that's a longer term development. But there is a framework for it already. It is a doable problem. It's just a matter of time and energy. Okay. If you're using the Rocket Workbench, you can get help in a number of places. I do have a number of YouTube tutorials. At this point, they concentrate mostly on the components and what the options are. But this list will expand. As I've mentioned, I've got unpublished videos at this point for exporting for 3D printing, for laser cutting, and for CNC printing. The wiki has a lot of documentation. It's a little behind because the development has been progressing very quickly. But in terms of the calculations, for example, keeping that up to date is a priority. In terms of the features, the components, how they're done is fairly up to date. Contact me on Twitter. This is where all the thinking happens. The origin of the Rocket Workbench was on Twitter. A number of features are quick conversations on Twitter. And yeah, for the most part, I do announce what I'm working on Twitter. But I'm also trying to keep the thread on the FreeCAD forum up to date. And there's also a thread on the Rocketry forum. I'm not as active on the Rocketry forum as I should be, but I am on there, and I do get notifications when messages are left there. How to contribute. Most people think you have to be a programmer to contribute to open source software. And if you are a programmer, yes, programming is a key element. One of the things that is underrated is feedback. Wouldn't it be nice if we had this feature? Like I said, a lot of that came out of very quick Twitter conversations. In a lot of cases, I am adding things that I think would be useful, but your problem set might be different. And there have been multiple occasions where I didn't have nose cone shape X. So it's like, oh, I didn't think that was in common use. So a couple days later, we had nose cone shape X. Or wouldn't it be nice to add those bars and crosses at the end of the nose cone? That all came through very brief conversations. So if you have a cockamamie idea that you don't think is useful, let me know anyway, because sometimes to someone it will be useful, and some are easy, some are less easy, but at least we can put it on the radar. Calculators. If you're doing something with a spreadsheet currently, it's a good candidate for a calculator. They're fairly easy to implement, often in a matter of days, and we can have it in the product. I put some in there that are I think are useful, but there's potential for others. Things such as if you're creating nozzles for experimental motors, we can create a calculator for something like that, or perhaps even a wizard that would draw those for you. So again, feature workflow recommendations, that's connected to what I just mentioned. Graphic design. So this is, if you're looking at the product here, all of these icons I did myself. I am not a graphic designer. All of these icons can be improved. If you are someone with skills in this area, by all means, get in touch and we can do better. Okay, so that's all I'm going to say about that. Documentation is always an area where we need work. If you've been involved in software in either capacity, you know that this is always a neglected piece of what's happening. Documentation takes many forms. There's the editing of the FreeCAD wiki. So if you just want to go in and spend an hour or two editing documents there. Creation of YouTube tutorials, for example, is another good way to document, and so on. If you are better skilled in languages than I, translations. There is a pretty active community for translation in FreeCAD, both as the core product and for workbenches like my own. So not just the Rocket Workbench, but all of FreeCAD can use your translation. If you are, in Indonesia, for example, we don't have a lot of Indonesian translations, so take it on yourself. Do a little bit. Every little bit helps. Testing, try it out, break it, send me a note. Okay, so can't emphasize that enough. I've been putting a lot of effort into automated testing recently, but you're never going to get 100% coverage. And there's always going to be that one Open Rocket file that just doesn't import, for example. So if you have issues, let me know. Right now, I'm working in a bit of a vacuum, so I'm not getting a lot of feedback, and I'm just making decisions based on what I think is right, but that may not best reflect the needs of the community. Okay, so that's the end of the presentation. Let's look at, oh yeah, you probably don't want the meta version there. The Q&A, there's a couple of questions. Does the software support Boost Glide, Rocket Glide models? So at the moment, no. This is an area where feedback is definitely going to be a requirement. I am not a builder of Boost Glide and Rocket Glide models myself. So how that would look is something that I would need to discuss with people with experience. So the challenge here isn't building a individual model. The challenge is in presenting this in a parametric form where we could cover the features required by most people. We're not going to 100% cover everything, but creating that streamlined workflow is really the challenge. Once that is worked out, then the actual drawing pieces are, it's not zero work, but it's well understood work. Okay. I think CFD will be very helpful in trying to improve aerodynamic calculations. Yes, absolutely. This is something that's going to require a lot of thought, though. There is a lot of math involved. My degree is actually in physics, but that was 30 years ago. So I can read the math, I can understand the math, I can't necessarily solve the math. And CFD as a topic is not something I've studied. My background is not in the engineering. If this is something that someone has skills in, then by all means, feel free to contribute. I've mentioned coding is not the only way to contribute, but having more coders than just me would be very helpful. But yeah, CFD, FEM, these are all things that I can definitely see as being useful. Okay, check the chat. Experiences with constants, yes. Constants are the bane of my existence, particularly since the US, which is the majority of people at this conference, obviously, does not use the metric system, and there are historical documents and things like that. Constants are really, really horrible to deal with, especially as you're reading like old NACA reports before really anyone in the world was using metric and so on. Just as another example, Open Motor, which is a open source project, very well written actually, which is surprising from engineers, and I'm going to slag them a bit here, does a very good job. I've tried porting that to FreeCAD with quite a bit of success, but the problem is they use meters and FreeCAD uses millimeters. So in those conversions, you're getting errors that are orders of magnitude in very small calculations, which show up in bigger calculations and so on. So it's definitely a problem. Okay, sorry, I was reading the next question. Can FreeCAD do exploded diagrams for kit documentation? Short answer is yes, but no. So FreeCAD has the option of building these, like if we look at the rocket assembly here, it will build these things using one of the assembly workbenches. And those are very good at building that exploded view. At the moment, this is more custom placement for the rocket workbench, so it doesn't have that capability. But it is actually a good example of why you should speak up, because this is not something I had considered, but should be possible to do. So I'm going to add that to the list of desired features, with the caveat that it's going to take a while to get to, because my immediate priority is getting these open rocket import and exports done. But that is an excellent suggestion. Yes. Okay, any other comments? Okay, so we've kind of reached the end of our time. I will let you go and have your lunch, and look forward to attending some of the other exciting sessions. So have a great rest of your day.